In this video, we're looking at doing some computations with the binomial probability distribution. So just like with other probability distributions, we can compute the mean and the standard deviation. In this case, though, we have some simplified formulas for this. So our expected value, or mean, is just n times p, and our standard deviation is the square root of npq. So for example, we have here a clinical trial of a cholesterol drug. 94 subjects were treated, and the likelihood of headaches with the drug is 6.8%. So treating this as a probability, as a binomial distribution, we're looking at a total number of 94 subjects. Some of them will get headaches, some of them won't. So we're treating our success as getting a headache, which means that P, our probability of success, is 6.8%, or 0.068. Q then would be 1 minus this. So if we compute the mean here, this is n times p, so 94 times 0.068. This comes out to 6.392. Now, this is really just taking 6.8% of 94, so it should make sense that this is how many people we would expect to get the headaches. But because each person is sort of an independent person, we might get more than this having headaches or fewer. Of course, since this isn't a whole number, we won't get exactly 6.392. But on average, with 94 subjects, we would expect about 6 to get headaches. Our standard deviation we can compute as well. We've got 94 times our p probability times our q probability, and then square root. So this comes out to 2.441 if we round to 3 decimal places. So remember what standard deviation means. This is sort of a measure of the average deviation from this 6 people. So we're expecting around 6, but on average the number of people in 94 subjects would vary by about 2. Another example here, this has to do with cryptography. When they look at breaking codes, one of the things that comes into play is how frequent each letter is. So in English, the letter E occurs 12.7% of all characters. So if we're looking at a transmission of 2,600 characters, how many would we expect to be E? So this expected value, this is our mean. This again is n times p, so this would be 2,600, the number of total characters we've got, times our probability of getting an E, or 12.7%. This comes out to 330.2, so this would be our expected value. Now if we were going to guess a number of E's, we might round this to 330, but that would be the average number coming up in 2,600 characters. Now if we got 331, that would not be unusual, that would not be surprising. This is just the average. Next, our standard deviation, we'll compute this as well, 2,600 times p times q. And our standard deviation comes out to just under 17. So this means that there's a pretty significant deviation from 330. On average, when you look at 2,600 characters, those are going to vary by about 17. So one thing that we can look at when we have the mean and the standard deviation is usual values. Remember that when we were talking about standard deviation, we said that if you look at the mean and then add or subtract 2 standard deviations, so 2 standard deviations on either side of the mean, these were sort of the usual values. And anything above or below these would be considered unusual. So here we're asking if we had a message that had 2,600 characters and the letter E came up 290 times, is this unusual? Well, the fact that 290 is less than our mean means that this is a low value. This is less than what we would expect. But to know if it's unusually low, we need to see what the range of usual values is. So if we look at the mean plus 2 times the standard deviation and the mean minus 2 times the standard deviation, we can get that range. So here we get a usual range between 296.244 and 364.156. Since 290 is less than our mean, we could just do the lower bound, but just to see what's going on here. So 290 is below our lowest value in the usual range, which means that we would conclude that 290 is unusually low. What this means in the cryptography sense is maybe our decryption is incorrect. Maybe this isn't in English, since this probability is based on English letters. But there's something sort of suspicious about this message. To finish up, here's a problem for you to try. You'll be computing the mean, standard deviation, and again you're looking at, in this case, at whether something is unusual. Again, we're going to use that rule of thumb of 2 standard deviations above and below as being our cutoffs. That's it for this video. See you next time.